that, the first thing, you start with the inside and then you work outside, okay? So we're gonna look at that g of -3 first. So we take g of -3, and we're gonna work with that first, 3x minus 1, okay? We get, equals 3 times -3 minus 1. And that is -9 minus 1, which is -10. And so then we're going to take that -10 and put it in for f, okay? So then we do f of -10 equals, everywhere you see an x in that one, you're going to put in a -10, so -10 squared minus 2 times -10. And that's 100, and negative times negative is a positive 20, which equals 120, which is answer choice D.
I have a question.
Yes.
Sorry. Can you just like repeat the steps on that one? I don't know why I'm so confused.
Yeah, so if it's f composed with g of x, write it in this form, right? So you do f of g of x, and then you work from the inside out. So we're going to do g of x first, and we find what that equals. And then we take whatever we found there and put it in for f. Okay, so first find the inside and then find the outside, whatever f is.
Oh, okay. So now I remember that we substituted f that's with whatever comes out of g.
Yes.
So we're
Yes.
working backwards. It's f of g, do g first. Sorry.
Yeah, do whatever, yeah, do the second guy first. So this g of x first, so you work from the inside out.
Thank you.
Alright, number 10 says, so it says, m of x equals the square root of x plus 1. And then m of x equals x plus 3. It wants to know m composed with m of x, right? And so, again, I rewrite it like m of x equals what? So for m, we're just going to put in whatever n equals into that equation, okay? So we're looking for m of, n is x plus 3, so m of x plus 3, which is the square root of, everywhere we see an x, we're going to put in an x plus 3 plus 1, okay? Which equals the square root of x plus 4. Any questions? Number 11 gives us this table.
So 10 was d.
Yes, 10 was, let me just make sure. Oh, and it wants the range, or the domain. Yeah, so we're left with that, and then the domain of this function, square roots, what's their rule? When they equal 0, give again.
You can't have a zero on the radical, right?
Yeah, zeros can't be in the denominator, but a square root, like the square root of 0 is 0, like 0 times 0 is 0. But can they be negative? No, they just can't be less than 0. So they have to be greater than or equal to 0. So we're going to take that x plus 4 -4, and then it has to be greater than it only, so all the way up to infinity. And that is, yes, that is answer choice D.
So how would you know to put a bracket? Yeah.
Because the square root can be greater than or equal to. And so over here we set it greater than or equal to. And because it's allowed to equal that, we say it's a bracket. Like if you were to draw it out on a number line, like here being -4, because it's greater than or equal to, that would be a closed dot, right? And it would go on that way, like for until infinity. And so, oh man, it keeps getting, right. And so because of that, because it goes from -4 to infinity with a closed dot, like including that -4, we do a bracket. But infinity, always a parentheses. So number 11, we are given this table, and it wants to know if it's 1-to-1. Okay, so what does it mean for something to be 1-to-1?
1x, 1y.
Yeah, 1x, 1y. So does that mean anything can be repeated? No, right? Every x has its own y and every y has its own x. So we're given this table. And it, like, is anything repeated at all in the table? No. So is it 1-to-1? Yes. Yes, it is. So number 11. Yes. 1-to-1.
So this one isn't the same as the first one, right?
No, so the first one was just asking if it was a function, which means like